Today on Cloud Security Lab Week, we're going to write our first IAM policy. As I keep saying, IAM is the heart and soul of AWS security. And there's a few basic components that we use to build the entire identity and access management setup within our accounts. The first is the principals. That's the IAM users and roles that we've already created. And if you remember, in both of those cases, we attached some existing policies that came out of the box. This week, we're going to learn how to write those policies ourselves. And so we're going to write our first custom IAM policy. Because IAM is the most important aspect of cloud security, and understanding permissions and writing policies is the most important part of IAM. Policies in AWS are incredibly powerful. They define what you're allowed or not allowed to do. It's basically a list of authorizations. And when we attach a policy to a user group or role, that becomes an entitlement. So it entitles that user to do something in our account. That's one of those IAM definitions like entity, and identity, and identifier that we use all over the place in security. In this case, an entitlement means the mapping of an identity or a persona to an authorization or a permission. Now, within AWS, they have a few different policy types that we're going to go through, as well as a specific policy language, and then there's some rules about how those policies are evaluated. Let's take about 5 minutes and run through those real quick, and I'm going to go over and pop over to my whiteboard here. Today, we're going to work with something known as identity-based policies. So these are the policies that we apply directly to users, groups, and roles that give them permission to do something or can deny them permission for doing something. Now, there's other kinds of policies. The main ones that we'll see and we'll get into later are resource policies. I got to learn how to spell. Something called service control policies, and then something known as permission boundaries. And again, we'll get into all of that as we get into the nuance over time. Now, we've already been working with identity-based policies, as I talked about. We used managed policies, and the kind that we used specifically was an AWS managed policies. AWS managed policy. Now, IAM policies didn't start with managed policies. They actually started with inline policies. And those are still supported. We try not to use them, but sometimes they do come into play and make sense. Because an inline policy is a policy that you write and you attach directly to a user group or role, and you never get to use that anywhere else. It lives as kind of part of that user group or role. When I started using IAM, which was right after Amazon released it to customers, that's all we had. And if I wanted to have, the same policy for 5 different roles and 3 different users, I would have to copy and paste that policy. And if I had to make a change to it, then I had to copy and paste those changes all over. So clearly that was unmanageable, which is where AWS managed policies came into play. Now, managed policies are cool. There's 2 different versions of those. A managed policy, before I get into it, is a centralized policy. So I can tab that policy in one place, and then I can attach it to a different users, groups, or roles. And if I make a change to that policy, that change instantly applies to everything that policy is attached to. There's those 2 different types, which we've got on the screen here. The first are the AWS managed, like the administrator access policy or the SSM managed instance core policy, the ones that we've already used. Those are built and managed for us by AWS. So all I have to do is take that managed policy, attach it to whatever I want to, and Amazon keeps that policy up to date. Now, that's good or bad. Now, the problem with those AWS managed policies a lot is they tend to over-permission. So it will, especially in the resources that it's allowed to be used for. And as you'll see in a moment, there's a resource field, so we can actually restrict what resources those individual actions are allowed on. And an AWS managed policy will never know what that is because it doesn't know what our resources are. That's why we have our customer managed policies. And a customer managed policy is a central managed policy that lives in our account that we write and we manage. By the way, another cool thing is versions are actually supported across these policies. Now, we don't want to be writing all of those by hand all the time. So how do we get started? Well, one cool thing you can do is you can just copy over an AWS managed policy, and then you can actually get rid of that star and add resources, say, to just your own specific S3 bucket. You can also add in conditions and make other changes. So I like AWS managed policies a lot. It gives me a good basis to start with. And then if I want to write my own policies, I can either start there or I can use some of the policies that I've written before. Now, Amazon policies all use a consistent policy language. As we've talked about, it's written in JSON. We went over JSON a little bit in our CloudFormation lab for those of you following in order. Other cloud providers, they also write their policies in JSON. So it's going to be important for you to get used to this, even if you're on Azure or Google. Every policy has a consistent structure. It always starts with the version, which is the language version that we're using in case Amazon makes changes over time. And then we have a block of statements. So statements are from 1 to n different allow or deny statements that are going to be evaluated. And we can have bunches of statements in any given policy. And you'll see that, or if you want, you can actually go ahead and look at some of the managed policies to get a sense of what those look like. A statement starts with the brackets, with the braces on each side. There's those brackets or those braces, whatever it's called. So the statement lives between those. And you can have this little symbol here in JSON means you have a list of them. So between those, we have the 3 core pieces of any policy. First, the effect. The effect is allow or deny. Can you do this or can you not do this? Now, everything in AWS is default deny, and you're only allowed to do what the allow statements let you do. But you can also have an explicit deny so that somebody can't say attach multiple policies and have an allow statement hidden away in there that you didn't expect or know about. So we do tend to use both those allow and those deny statements, even though everything is default deny. Then we have the action. And the action, well, this is the API calls. Entitlements map directly to the API calls you're allowed to make. So we have our service listed here, S3, and then get object, which is read, and put object, which is write. So in this case, this policy says allow reading or writing of S3 in the last piece, which is the resource. And in this case, it's a single S3 bucket. Now, it could be a list of resources, or it could also be a wildcard, but we talked about how you want to minimize your wildcards. You will notice that there's a little wildcard at the end here because any given bucket will have multiple objects. And so that's why we have to have that. It'll make sense once we actually get into the hands-on portion. Now that's it. That is the basics of every IAM policy. It's going to have those 4 consistent elements. It's going to have a version. It's going to have statements, and it can have, again, a lot of statements in there. It's going to have the actions, which you're allowed to do, and then it's going to have the resources. There's also conditions, which we're not going to get into today, because conditions is where you get into a lot of the more advanced stuff that starts becoming more fun and gives you a lot of the extra power and granularity of AWS policies. Okay, now, how does Amazon actually look at all of these pieces together? So there's rules to the policies. And the rules are everything in AWS is default deny. I mentioned that before. I will mention it again. It's really important to understand. You only get permissions for what you have explicit allow permissions for. It's a default deny, and then it is a logical sum of all of the policy statements and all of the policies attached to a principal. So if you have, say, 12 different IAM policies attached to an IAM user, it's what you're allowed to do is going to be the logical sum of all of the allow statements, but any deny statements in there will override any of the allow statements. That's why those explicit denies are so important, because it means that if you have multiple policies and you don't want somebody to actually be able to do something, somebody can't attach a policy with permissions that can override those deny statements. I know it seems confusing, makes a ton of sense once you kind of get into the weeds on this thing. So default deny, it's a logical sum of all the allow statements, and then any denies will override any or all of the allow statements. Let's review a few key points, and then we'll get into the lab itself. IAM policies are the heart of AWS security. They define who or what is allowed to perform which actions. And when we attach those to an IAM user or group or role, that creates an entitlement. There's lots of different kinds of policies. Today, we're going to be using the identity-based policies, which are the ones that do apply to those users and roles, the identities. A permission is called an authorization, which we call auth Z in security speak. I don't know why, actually. Someday I'll find out. And assigning a permission to a principal like a user is called an entitlement. And again, as a review, I know I went over it 3 times. This is going to be the 4th time. AWS IAM policies are a logical sum of all of the applied policies, but any deny statement will override any allow statements. So like if you're logged in as a full admin user and somebody attaches a second policy with the statement that says deny run instances, you won't be able to run instances. And policies, lastly, are written in JSON with a strict syntax. You might find it helpful. There's a lot of JSON validators online. I actually have a local tool I use that you might see me use in a couple of these labs that'll go through and help me find any of my syntax errors. So that's really helpful to have some of those if you get kind of hung up on the policy language of JSON, because even though I know it really well, I still make mistakes. Okay, that's it for the background lecture. Let's go ahead and jump into the lab itself. Our first IAM policy, it's going to be a pretty simple one. It's pretty much exactly what you saw as I was writing out and showing you the policy language or the JSON, except we're going to have it specific for an S3 bucket in your account. Now, we haven't created any, but wait, we have. We have the S3 bucket that is for your CloudTrail. So that's the one we're going to use today. Make this work, let's go ahead and first get the Amazon resource name for that S3 bucket. So we'll go to S3. I just had it on my list, but if you need to, you click up there to search on it and then click over to S3. And you'll notice I've got one at the bottom here because I was playing around with CloudFormation templates. Ignore that and click on your AWS CloudTrail logs bucket. Now, this is not too dissimilar to a policy that you might create in the real world to allow somebody access to the bucket if they don't have administrative access to your account, like a developer who needs to keep track of any error messages that are cropping up. And if I click on properties, then I'll have the ARN listed right then and there. Now, to make things a little bit easier, I want to go ahead into the corner here and open up a new tab into the console. And this time we're going to go over to IAM. I do this a lot so that I can just copy and paste resource names and stuff from one place to the other without having to put it on a scrap sheet of paper. Now we don't use paper. All right, so within IAM, let's click on policies. And you can see that there are, a lot of policies. 1,169 managed policies by default out of the box that Amazon gives you. Trust me, as somebody used to have to write everything from scratch, it's kind of cool to see this. We're not going to use any of them. Instead, we're going to go into the upper right-hand corner and create our own policy. Now, you can do this directly in JSON, and that's really what I tend to focus on and how I write my policies. But I do want to show you the visual editor because it's a little bit easier when you first get started, and it's also a place that's going to let you see all of the possible actions. Now, any of these policy statements are going to be specific to an Amazon service. So I'm going to go click Service and S3. Then I have all of the potential actions allowed. These are the actual API calls that are supported by the S3 service. And I don't want to look at list. We're going to go into read. And if you recall from when I was walking through the JSON, we want to use the get object. That's going to allow me to read the objects or the files that are in that S3 bucket. Now, you'd think it would be in alphabetical order and I'd come down here and see get object, but nope, things go left to right. Get object is over here. Now, there's an easier way. And by the way, as soon as I check that box, that's added. And then let me compress that down. Another way to get to the actual statements is to use this filter. So if I put in, say, put objects, it's going to pull those up, all the places where that appears in any of those API calls, and I can just check it there. So if you want, you're more than happy to go ahead and click the list of everything to find the one that you want to pick. But you'll see here that I find it easier to type into the filter actions. Either way, as soon as you check the box, that gets added to the list of actions. Also, we have the choice between allow or deny, and as we reviewed, we're going to go just with allow statements today. Then we go to our resources. Now, does this all make sense? It's similar to that statement structure we talked about. You have the action, which is allow or deny. You have the effect, which is allow or deny. You have the action, and then you have the resource. And we want to do a specific resource. Let's click this Add ARN to add in our specific Amazon resource name, because we don't want to leave it for everything. I'm going to click back over to my tab, and I'm going to copy out that ARN. Then I'm going to go back to the Create Policy tab, paste it in, and when I hit Add ARNs, I get an error. Now, I did that on purpose. The reason is this ARN is for a bucket, but the actions we picked were to get an object or to put an object. There's an easy fix here, which is to add a slash and then an asterisk. Now let me zoom out, confirm add ARNs. Okay, now I've put that together properly. If I switch over to the JSON, you'll actually see it written out completely. So I have it just like when we did our little whiteboarding diagram with the statement. And in this case, it's adding a statement ID. You don't have to have those. The essential elements are the version, the statement, the effect, the action, and the resource. And unlike my demo, which you can actually see here that we talked about before, where I didn't have a fully valid ARN, in this case, I have a fully valid ARN that exists in my account, and I know that works because it was actually validated. All right, let me zoom out a little bit. So that's what it looks like on the visual side, and that's what it looks like on the JSON side. Now, you can actually add additional statements here and do stuff on JSON with a little bit of search. I do recommend that you play with that and spend more time with it, because that really is the better way to go ahead and create these. And if you want to see what the actual raw JSON looks like, you can go back to the blog post and get a look. This is exactly what we created. Now, this permission policy is actually a little bit of overprivilege. You can imagine that I might want to give a developer access to the CloudTrail logs so that they can read the logs and find any mistakes or errors that are generated by the work that they're working on. But in this case, I'm allowing them to make changes or to put other objects in those logs. So we're not really going to use this policy later, but it's a good one just to get a sense of what it looks like. And we'll come back to it, and we'll probably replace that resource name. So this isn't a huge security issue to have this existing in our accounts. I just want you to be aware of that. All right, we've got it written. Let's go down and click Next. And we have to give it a policy name. And I'm going to call it CloudTrail read. Whoops, can't really spell today. Right. So that's going to allow me to allow read and write access to our main CloudTrail bucket. It is important to put in these descriptions and the policy names, because other people are going to go ahead and have to look at these things later. And if you just have a bunch of like weird names, it's hard to track it. We've got our name in place. We have our description in place. We have our permissions. This tells us we have limited read and write access to a specific resource within the S3 service, and create policy. Boom. Now, if I click on filter by type, I have customer managed policies, and I can see my policy here. I can hit the plus button, and I'm going to see that raw JSON. I can even copy it out, paste it someplace else, or edit the policy. Any changes made to this policy will apply to every user, group, and role that policy is attached to. That's a really simple IAM policy. We're just getting started. We're going to write tons of these over in the future, but this is designed to give you a sense of the main policy elements, as well as how to use the policy editor within AWS. That's it. See you next week.